a mile-wide rock hurtling toward Earth at 45,000 miles per hour. This isn't a sci-fi movie. It's a real possibility, and maybe closer than you think. What if I told you that in 2023, an asteroid the size of a skyscraper passed between Earth and our communications satellites, and NASA only detected it 24 hours before? What if I told you we miss dozens of potentially dangerous asteroids every year? What if next time it's not a near miss? Imagine waking up to a breaking news alert. A massive asteroid is on a collision course with Earth. Governments scrambling, scientists running calculations, the world holding its breath. How much time would we have? What would you do with your final days? And the question we're all afraid to ask: could we actually stop it? The cosmic clock isn't just ticking, it's roaring like a countdown to extinction. But here's the real question that keeps astronomers up at night. Are we ready? In the next few minutes of your life, you'll explore the asteroid threat like never before. You'll discover which asteroids are most likely to hit us and how soon, the shocking blind spots in our planetary defense system, the terrifying reality of how little warning we might actually get, and whether our current defense technology stands a chance. Plus, I'll reveal the one asteroid that astronomers privately fear could change course and impact Earth within our lifetime. The stakes couldn't be higher. This isn't science fiction. It's an extinction-level reality check. Before we talk about stopping them, let's understand what we're up against. What exactly is an asteroid? Asteroids are massive rocky or metallic objects, mostly from the asteroid belt between Mars and Jupiter. The smallest are the size of a car, but others are truly massive, like Ceres, which is nearly 600 miles across. For perspective, an asteroid just 6 miles wide created the impact that killed the dinosaurs. But asteroids aren't the only threats from space. Comets are icy, fast-moving space objects from the outer solar system. When they approach the sun, they heat up and create those stunning tails we see in photos. What makes them particularly dangerous is their unpredictable paths and high velocities. A comet impact would be catastrophically more powerful than an asteroid of the same size. Meteors are much smaller, often burning up harmlessly in our atmosphere as shooting stars. But sometimes they make it through, like the Chelyabinsk meteor, which exploded over Russia in 2013, creating a blast 30 times more powerful than the Hiroshima bomb, and injuring over 1,500 people. And that was just 20 meters wide. Now here's where it gets truly frightening. Not all asteroids move the same way. While many follow predictable orbits, others are subject to what scientists call the Yarkovsky effect, where sunlight itself can gradually alter an asteroid's trajectory. Others get gravitational kicks from planets they pass, suddenly changing course. That's where the real danger lies. And the most chilling part? We're essentially playing a cosmic lottery, where the odds of an impact are 100% given enough time. The only questions are when and how big. But what really keeps planetary defense experts awake at night isn't the asteroids we're tracking. It's the ones we haven't found yet. And as you're about to discover, our detection capabilities have frightening limitations. Ask yourself this: if an asteroid were heading straight for your hometown right now, how much warning would you actually get? Let's talk hard numbers. How often do asteroids actually hit Earth? Small asteroids hit Earth daily, but they burn up in our atmosphere, creating those beautiful shooting stars. Medium-sized asteroids, capable of destroying a city, strike roughly once every few centuries. Regional devastators, like the Tunguska event, about once every 1,000 years. Planet-threatening asteroids? Every several million years. The most famous impact, the Chicxulub asteroid, wiped out 75% of all species, including the dinosaurs, 66 million years ago. It released energy equivalent to 10 billion Hiroshima bombs. But let's focus on modern times because asteroids don't check historical schedules. In 1908, a massive explosion flattened 800 square miles of forest in Tunguska, Siberia, an area larger than New York City. Scientists believe it was caused by an asteroid or comet fragment just 60 meters wide. Had it arrived just hours later due to Earth's rotation, it could have obliterated St. Petersburg, Russia, killing millions. More recently, in 2013, the Chelyabinsk meteor exploded over Russia with no warning whatsoever. Despite being relatively small, its airburst shattered windows across 6 cities and caused structural damage to thousands of buildings. Now, here's the real twist that NASA doesn't advertise. Some asteroids aren't discovered until after they pass Earth. In 2019, asteroid 2019 OK, roughly the size of a football field, zipped past us at just 70,000 kilometers away, 1/5 the distance to the moon. And we detected it only 24 hours before closest approach. Had it hit, it would have devastated an area the size of a major metropolitan city. And in 2020, asteroid 2020 QG became the closest known non-impacting asteroid, passing just 1,830 miles above the Indian Ocean. And we only spotted it 6 hours after it had already passed by. What if next time we don't see it at all until it's entering our atmosphere? Based on the statistical models, the probability of a city-destroying asteroid impact in your lifetime is small, but significantly higher than winning the lottery, being struck by lightning, or dying in a plane crash. And unlike those other risks, an asteroid impact could affect millions simultaneously. With the vastness of space and the relatively small size of these cosmic threats, finding asteroids before they find us is like searching for a bullet in a haystack while wearing a blindfold. And our detection capabilities have one fatal flaw that could mean the difference between salvation and catastrophe. You might be wondering, don't we have advanced telescopes watching the skies 24/7? The answer is yes, but with some major limitations that should concern us all. First, the numbers problem. Space is unimaginably vast. Even with powerful telescopes, we're essentially trying to spot dark rocks against the black backdrop of space. Many asteroids are also extremely dark, reflecting as little as 3% of the sunlight that hits them, making them nearly invisible until they're dangerously close. But the technical challenges go much deeper. Asteroids approaching from the sun's direction are nearly impossible to detect until it's too late, as our telescopes can't look directly at the sun without damage. This creates a massive blind spot in our planetary defense. Smaller asteroids don't reflect much light, making them hard to spot until they're very close to Earth. An asteroid 50 meters wide capable of destroying an entire city might only be detectable a few days before impact. Some asteroids have highly elliptical orbits, meaning they only come near Earth once in a long while, giving us fewer opportunities to discover them before they become threats. Limited resources mean we simply don't have enough telescopes dedicated to asteroid detection. Most of astronomy's focus and funding goes to other scientific pursuits. Even with advanced detection systems like Pan-STARRS, Atlas, and the upcoming NEO Surveyor, which will use infrared to spot asteroids from space, there are significant blind spots in our planetary defense network. The NEO Surveyor, scheduled for launch in 2026, will dramatically improve our detection capabilities by observing in infrared wavelengths from an orbit similar to Venus, allowing it to spot asteroids coming from the sun's direction. But until then, we remain vulnerable to surprise. Consider this sobering fact. In a 2019 NASA planetary defense exercise, experts were presented with a scenario of an asteroid on a collision course with Earth. Their conclusion? With current technology, if an asteroid smaller than 50 meters was approaching from the direction of the sun, we would have zero warning until it entered our atmosphere. So, if an asteroid were headed straight for us right now, how soon would we know? For smaller city killers, potentially just days or hours. For larger objects, we might have months or years, but only if it approaches from a direction we're watching. And that's assuming our existing detection systems spot it at all. But let's assume we do spot an asteroid on a collision course with Earth. The clock is ticking. What options do we actually have? Is Bruce Willis standing by with a nuclear weapon our only hope? As it turns out, science has some better ideas, but they all depend on one critical factor. Let's say NASA discovers an asteroid on a collision course with Earth. What's the plan? Scientists have several defense strategies, and they've been developing and testing them with increasing urgency. 1. Kinetic impactor. The simplest approach, slamming a spacecraft into the asteroid at high speed to change its path. This isn't just theoretical. NASA's DART mission successfully altered the orbit of asteroid Dimorphos in 2022 by deliberately crashing into it. The impact changed the asteroid's orbital period by 32 minutes, proving we can actually move these cosmic bodies. 2. Gravity tractor. A more gentle approach where a spacecraft hovers near an asteroid for months or years, using mutual gravitational attraction to slowly pull it off course. While slower, this method avoids the risk of breaking up the asteroid into multiple dangerous pieces. 3. Ion beam. Deflection, using ion thrusters to direct a stream of charged particles at the asteroid, gradually pushing it off course through continuous pressure. 4. Nuclear detonation. The most extreme option, using a nuclear explosion near, not on, the asteroid to push it away through radiation pressure. This method could deflect even very large asteroids with relatively little warning time, but carries significant risks, including creating dangerous debris clouds. But here's the critical problem. All of these methods require time, the one thing we might not have. If we detect an asteroid only a few months before impact, most of these methods would be impossible to implement. Even the nuclear option would require months of preparation. This brings us to the uncomfortable truth. Early detection is everything. The sooner we see the threat, the better our chances of survival. So, should we be worried? Are we ready for an asteroid impact?